All right, this is lesson 7.7, exponential shifts. So exponents have two graphs. There's growth where it's going up to the right and decay where it's going down to the right. So all of these graphs start at 0, 1 as the parent function. So they have a y-intercept of 1. So the first thing I want you guys to do is to go ahead and write the general form of an exponential function at the top of your paper. So we have y equals a times b to the x. So that lets you know that the y-intercept is this a, and then the b is your multiplier, which is also known as your proportional rate of change. So x in the exponent makes it exponential, x exponent exponential. So this is our parent function. So the parent function is 2 with the exponent x. It has a y-intercept, just like the graph shows. It has a y-intercept of 0, 1. And then the asymptote is the line, the imaginary line that your graph approaches but never touches. So in this case, we can see that that parabola on the left side starts to kind of flatten out, and it seems like it's never going to touch, or maybe that it might eventually run into the x-axis, but I assure you it does not. So the asymptote in this case is where y equals 0. So it's that dotted line that represents the equation y equals 0. So that green line is going to get really close to that x-axis, but it's never going to touch it. That's the asymptote, the imaginary line that your graph approaches but never touches. So now we've got this next one. So outside the parentheses, there's this plus 3. So we've talked about in the past, at the very end, if we've added 3, it shifted our graph up 3 units. This is nothing different. This is still a translation up 3. So our parent function started at 0, 1. And I'm going to draw the parent function just on this. Actually, I'm going to draw it on all of them just to make sure that we have everything right. So looking at the parent function, 1, 2 is the next ordered pair. And then 2, 4, so 2, 4. And then everything over on the on the left side gets closer and closer to that x-axis. So half, a quarter, etc. So if my parent function is represented by this line, and I want it to go up 3 units, that means I'm going to take all of these ordered pairs that we've already plotted on here and shift them up 3. So my new y-intercept is there. This one we go 1, 2, 3 is there. This one, 1, 2, 3. 1, 2, 3. Even the asymptote has moved up 3 units. So where our asymptote before was on the x-axis, this one is going to be up 3 and be up here at the y value of 3. So when you draw your line, you want it to get close to that red dotted line but not touch it. So our new y-intercept from moving it up 3 units is 0, 4. And our asymptote after moving it up 3 units is now y equals 3. So then down to the next one. Again, I'm going to draw the parent function on each of these because it helps you move these graphs. So parent function was like this, and I'm just copying those points straight from the one up above. We know the asymptote, that imaginary line, was the same as the x-axis, which is y equals 0. So this next one, in the parentheses, we have an x minus 3. So just like on quadratics and just like on linears, inside the parentheses affects your input values, your x values, left and right. So because this one says -3, we change our thinking inside, and this one's going to be a translation to the right 3. So each of these ordered pairs that we've already plotted based on our parent function, we're going to shift them to the right 3 units. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And then draw your curve. So all it did was shift our graph to the right 3. But now our y-intercept is a little bit different. So we were at 4, moving from right to left because I want to backtrack. I go from 4 to 2 to 1 to half. So every single time I'm cutting my number in half when I'm moving to the left. I'm multiplying by 2 going to the right because that's my multiplier in my fraction. So if we want to backtrack though, if we want to reverse directions, we have to do the opposite math. So we were at 4, and then 2, then 1. 1 divided by 2 is half. Half divided by 2 is 1/4. And 1/4 divided by 2 is 0.125. So your y-intercept is 0.125. So you could also use the calculator and scroll up and find your y value or your y-intercept by finding the x value 0. So you could plug this in under the table function on your calculator and find your y-intercept that way as well. So the asymptote, we didn't move it up or down at all. So the asymptote is still y equals 0 because all we did was we shifted it to the right, not up or down. So the next one, we have a -1 in front, which lets us know that the negative always tells us that it's a reflection over the x-axis. So again, I'm going to draw my parent function because it helps me see where everything goes. So I have half, 1, 2, 4. We have an asymptote of 0, 0. I have y equals 0. So if I'm going to reflect this over the x-axis, this 1 that's my y-intercept is 1 unit to the x-axis. So I have to go 1 beyond because a reflection should be symmetric. So at 1, 2, this ordered pair, it's 2 to the line of reflection. So we're going to go 2 beyond it. The next one at 2, 4, it's 4 to the line of reflection. So we're going to go 4 beyond it. And then draw your line. So now this one has a y-intercept of 0, -1, but the asymptote is still y equals 0. It's where your line kind of bottoms out. So on the back, this time we have an a value. So that value at the very front of 4. So this is going to be just like in quadratics, just like in linear. When we put a number in the very front, it represented a vertical stretch or a horizontal shrink. So this one is a vertical stretch with a scale factor 4. So when we do this, our parent function is first. And where it bottoms out is that asymptote. So if we're going to take each of these and stretch it by a scale factor of 4, we're going to multiply each of our y values by 4. So we have our y-intercept was 0, 1. 1 times 4 is 4. So that's my new point on that section. So then we have 1, 2. The y value is 2. Multiplied by 4 would be 8. So it's going to be somewhere way up above our graph. So we're going to try the other points. So to the left, at this -1, we have half. Half of 4, because our scale factor is 4, so 4 times half is 2. So then our next one is about a quarter. So a quarter times 4, 4 quarters is 1 whole. And then it's going to just slowly approach 0. So we know this one's coming from way up high. And it's going to look about like that. So now our y-intercept is 0, 4. And the asymptote is still the x-axis, which is y equals 0. So the next one. Again, I'm going to keep drawing my parent function because it helps me graph these. So then when I look at my equation, I have half of the parent function. So this is going to be a horizontal stretch. Which is the same as a vertical shrink by a scale factor of 1/2. So each of those y values that we already have, instead of multiplying them by 4 like we did in the previous problem, in this one we're going to multiply them by half. So I'm going to start at my y-intercept. Half of 1 is half. My next ordered pair is 1, 2, so half of 2 is 1. My next ordered pair is 2, 4. Half of 4 is 2. So this one is going to look approximately like that. So our new y-intercept is 0, half. You could also put 0, 0.5. And our asymptote hasn't changed. It still kind of bottoms out at the x-axis, which is y equals 0. So asymptotes are always y equals a number. Okay, so the next one. There's multiple things going on in this one. So we have our +2 on the inside, and you always change the inside. Inside is your inputs left and right, so this one is a translation left 2. And on the outside, it affects your outputs, which is up and down, so -2 means you go down 2. So when I draw my parent function, I know that I'm going to take each of those ordered pairs and I'm going to move them left 2, down 2. So I have this one, the y-intercept, left 2, down 2 is now right here. 1, 2, this ordered pair goes left 2, down 2. Now it's right here. My next ordered pair, 2, 4, goes left 2 and down 2. So now it's right here. And I'm going to choose another one really quick just to help me see it. So we have, that's our new function. So it has a y-intercept of 0, 2. And it looks like it's bottoming out right here, which would be y equals -2. So the last one, we have a number in the front, which represents our vertical stretch because that number is larger than 1. So this has a vertical stretch, which is the same as a horizontal shrink, with a scale factor 3. So there's nothing happening with the x value, so we're not going to move it left or right. We only have this -4 at the end, which is outside the parentheses, so it's our output values. So we go down 4. So when we go to graph this one, again, I'm going to graph the parent function just to help me see it. And then I'm going to take this and I'm going to go down 4 and then apply my scale factor 3. Sorry, I'm going to do that the other way around. I'm going to do scale factor 3. So my value, so my scale factor 3, this y value of 1 at our y-intercept, 1 times 3 is 3. And then I'm going to shift that down 4 units, which puts me here. So then I look at my next ordered pair, 1, 2. So 2 times 3, my scale factor is 6. And then I move it down 4. So 6, 1, 2, 3, 4 puts me right here. So then I can try some of these other ordered pairs. So we have half on a scale factor 3 would be 3 halves, 1.5. So it's about right here. And then move it down 4. So 1, 2, 3, 4. So now we can go ahead and draw the basic shape of this function. So because it's going to go down 4, that means your asymptote is now down here at -4. So when you draw your exponential function, you want it to bottom out, to flatten the curve at -4. So the asymptote is y equals -4. The y-intercept is now 0, -1. So we applied a vertical stretch by a scale factor 3. So multiply your y values by 3 and then translate them, shift them down 4 units. So these are representing decay. So the parent function for decay that we're going to use is this y equals half to the x. So we're going to go ahead and draw that on here. So we've got, this is your parent function. I wish they'd drawn this on here for you guys. So if we're going to take that parent function, y equals half to the x minus 4. That minus 4 is on the outside, so it tells us we go down 4. So we're going to take that entire graph and shift it down 4 units. Which is going to give us a graph like this. So our original asymptote was right here at y equals 0. Because we shifted it down 4, now it's down here at y equals -4. Our y-intercept is now 0, -3. So now our next one. Again, if it helps you to draw the parent function, draw it. It helps me, which is why I draw it every time. So on this one, we're going to move it x plus 3. Remember, if it's in the parentheses, it affects your input values, your x values. So we change the inside thinking as well. So this is actually left 3. So each of those dots on our parent function, we're going to move them to the left 3. And it's going to give us this. So we didn't change how far up or down it went, so the asymptote is still y equals 0. And our y-intercept is now something we have to calculate. So we can go 1/2, 1/4, 1/8. So that's that 0.125, half of a quarter. Again, that's another thing you can use the function on your calculator for plugging in and finding the table. That's fine. All right, next one. So this one, we have our parent function, drawing it each time. I noticed that it is multiplied by a scale factor 2, so that's going to be a vertical stretch. By a scale factor of 2. And then outside the parentheses there at the end, we have a -2. So then it's also going to translate down 2. So the first thing I want to do is multiply each of those y values associated with each point on the parent function by 2, and then I'm going to take it down 2. So I'm going to start with this one, -1, 2. So 2 times 2 is 4. Drop it down 2 is here. So then we have 1 times 2 is 2. Shift it down 2, puts it there. 1/2 times 2 is 1. Shift it down 2, it's here. And then you can continue following that fashion until you get to the end. So I also noticed with this down 2, that means my asymptote is down here at -2. So I'm going down 2, so the asymptote is at -2. So when I draw my line, I know that's where I'm going to bottom out this graph. So the last one, we have our parent function. So -2, 4, -1, 2, 0, 1, 1/2, 2 1/4. So when we look at our function, the only thing that's changed is now there's a negative in front of it. So that means it is a reflection over the x-axis. So when we reflect it, our line of reflection is the x-axis. So this point is 2 to the line of reflection, so it's going to move 2 beyond it. This next point is 4 to the line of reflection, so we're going to go 4 beyond it. And this is your transformation. So it still has an asymptote, still bottoms out at y equals 0. Now that we've reflected it, our y-intercept is 0, -1. So as a quick summary, when you're in the exponent, you move left or right, and it says think opposites. When you are at the back end of the equation, you move, this is your asymptote. So every time we've shifted it up or down, our asymptote has shifted in the same direction, the same number of units. So this is your asymptote. And it shifts you up or down. So the difference between growth and decay is the base. So if your base is greater than 1, it represents growth. If your base is between 0 and 1, it's decay. So the last problems are exactly like what we were doing in the last lesson at the end. So the first thing I want you guys to do is write all of your formulas at the top. So we have exponential is y equals a times b to the x minus h plus k. So we're following along with the same exact letters that we've used throughout. And we know it's exponential because x is in the exponent. So then for a linear function, it's the same thing we wrote on the other paper. So linear is y equals a x minus h plus k. And with linear, there's no exponents. And lastly, with quadratics, we have y equals a x minus h squared plus k. So you know it's quadratic because there's 2 in the exponent. So then when you come down to these word problems where we're writing the equations, we're going to do exactly like we did last time. We're going to pick some colors and represent it. So I'm going to make exponential blue. So where I see the word exponential, I'm highlighting it in blue. So then I'm going to make my linears this orangey color. So where it says a line, and then I'm going to make my quadratics green. So I see quadratic, quadratic, which means I'm going to use the quadratic formula. So an exponential growth. So the key word there is growth. So we know it's going to be y equals a times 2. So remember, b is going to be 2 for growth, half for decay, as far as our base units go. So it's 2x minus h plus k. So it's exponential growth. We've shown that with the 2. It's been shifted right 5 units. So that means our h value, because that's our horizontal shift, is a 5. And down 3 units. So my vertical shift is down 3. Now, because they haven't mentioned any kind of vertical stretch, horizontal stretch, or any shrinks, that a value just is 1. Because anything times 1 does not change its value. So the next one is a quadratic. So this is y equals a x minus h squared plus k. So it has been reflected. That's the very first thing. It's been reflected. So that means we know the A value is -1 or a negative. Reflected over the x-axis. And then it was shifted left 3. So that's a -3. So we're erasing our h for our horizontal shift and putting a -3. It doesn't tell us any shift up or down, so I'm just going to erase that plus k, and then we're going to rewrite this so that it's prettier. So we have y equals negative, instead of minus a negative, we're going to put plus 3 squared. So now we have an exponential decay, which lets me know that that base value is going to be a half. So we have y equals a times a half x minus h plus k. So it's been vertically stretched by a scale factor 10. So that means that a value is 10. There is no horizontal stretch, so I can just erase that. There's no vertical stretch, so I can erase that. And the only thing we're left with is y equals 10 times half to the x. So our next one being exponential growth, I know that I'm going to have a 2 in the parentheses. So we have y equals a times 2 with the x minus h in the exponent and a plus k. So it says an asymptote of 4. We talked about already that the asymptote follows that vertical shift. So if it's an asymptote of 4, that means it's been shifted up 4 units. We do that by putting a big plus 4 at the end. And then it says it's moved right 2 units. So right is your horizontal shift, and it's moved right 2 units. Now it didn't give us a vertical or horizontal shrink or stretch, so we just let go of the A. It's 1. It changes nothing. So I want you guys to use the last 4 problems to practice on your own, plugging into these formulas based on the words, the verbal descriptions given to you, and then get on Canvas later and check your answers.